Geometry Unit, Section 3, Area. When you want to know how much surface an object has, you're looking for a two-dimensional measurement called area. Knowing the area of something can help you answer questions like, how many acres are in this field? How large is this house? How much paint do I need to paint this wall? How much will it cost to carpet this floor? In theory, to determine the area of an object, we're going to divide it into small squares. The size and number of those squares is the area. Let's determine the area of the rectangle shown here in square feet. Since we are to find the area in square feet, we must determine the number of 1 foot squares that will fit in this rectangle. Because each side of this 1 square foot square has a length of 1 foot, it's called a 1 square foot. The diagram shows we ended up with 8 squares fitting inside this rectangle. Therefore, the area of this rectangle is 8 square feet. What if we were to use a different unit of measure, for example, square inches? 1 square inch is much smaller unit of measurement than 1 square foot. It will take a lot more square inches to describe the same amount of surface. As a matter of fact, we end up with 1,152 square inches for this same shape that we just found in square feet. Applications for why we need area could be in a building project. To determine the cost to build, we need to know the area of the floors for plywood, subfloor, flooring of some type, interior walls, whether it's sheetrock followed by paint, exterior walls could be the house wrap for weatherproofing, foam board insulation, bricks, siding, so on, and even the roofing as far as determining the cost to build a house. We're interested in the amount of shingles is dependent upon the area, tar paper, and even as a matter of nails. The amount to purchase depends the area to be covered. To determine the area, we have some formulas for basic shapes. Each shape has a unique formula. And here for a square, a rectangle, parallelogram, trapezoid, triangle, and circle each have different formulas. Each formula requires us to use a specific length. And here we'll take a little time to look at each one. To determine the area of a rectangle, we're going to take the length times the width, and abbreviated L times W. In a parallelogram, the formula is base times height. And if you look at a parallelogram and cut where this dashed green line is, remove that piece and place it to the left-hand side, all of a sudden we've got the rectangle shape that we just looked at a minute ago. This is the basis for the formula then for the area of a parallelogram. We take the height, the distance between two parallel sides, times the length of a parallel side. Base times height. A triangle has base and height in its measurement, which sounds like the parallelogram or rectangle that we just had a minute ago, but this isn't triangular. If we remove half of this figure, we now have our triangle, and here's where the basis of the formula is derived from taking the base times the height, the vertical distance, dividing it by 2. And instead of dividing by 2, we could multiply by 1/2 or use the decimal equivalency 0.5. In a trapezoid, it has the basis of area formula for a rectangle or a parallelogram, but here are bases. We have 2 different lengths. Which one to use? Best bet is to find an average of those 2 bases. That derives a rectangular shape by taking the average of those 2 parallel sides in a trapezoid, and a trapezoid only has 1 pair of parallel sides, taking that average length and timesing it by the height. So here's our formula for the area of a trapezoid. And then this example, we're going to take the bases. We're using the subscript B1 and B2 for those. We're going to average those 2 lengths. They're the sides that are parallel to one another. We'll add 62 and 85 and divide the result by 2, which gives us an average base length of 73.5. Now we're ready to go ahead and multiply by the height, the distance between those 2 parallel sides, to give us a final area or figure for this trapezoid. Feet times feet result in square feet, as all area problems have square units. So generalizing this formula for the area of a trapezoid, we're going to take the 2 base lengths, add them together, divide that by 2, and times it by the height. The area of a circle can be found by taking the diameter, timesing it by itself, which we're using a shorthand here of diameter squared, multiplying that by pi, 3.14, and dividing the result by 4. You may have in a previous math class also seen the area of a circle with the formula represented by taking pi times the radius squared. Either one will give us the same area value. To determine the area, some steps to solve. For example, for a parallelogram, we need to first determine the correct formula for the parallelogram, base times height. Next, we need to determine which measurements are the appropriate ones to use. We need the base and the perpendicular height to the opposite side of that base measurement. So in this example, the 9 inches, that length of that slant height edge is not used. We're going to take our 15 base times 7 base, multiply together, giving us 105 inches times inches, square inches for the area of this parallelogram. You're now ready to do some practice found on page 30 and 31.